Hello everyone, this is Jie Pan from 598 seminar class. This video will show 5 sorting algorithm animation with 2 different datasets. This animation code is referenced by the ZoffZhang and modified by me. And the reference link is on the right top corner. And there is 5 sorting algorithm: insertion, selection, bubble, merge, and quick. And for the dataset, there's 2. First is random, and second one the reverse. For the random one, dataset is just random number in the random place. For the reverse one, it's just like the random number in reverse order to test the worst case. First, I will introduce the insertion sort. The insertion sort is a simple sorting algorithm that builds a final sorted array one atom at a time. It is much less efficient on large lists than more advanced algorithms such as quicksort, heap sort, or merge sort. So I show in the application. The first I will show you in the random order, random dataset. Yeah, that's it. And then with the reversed dataset to see the worst case one. That's it. Really slow. And for the second one, I introduced the selection sort. And first, I introduced it. The selection sort is a simple algorithm. Like this sorting algorithm is an in-place comparison-based algorithm in which the list is divided into 2 parts: the sorted part at the left end and the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list. The smallest element is selected from the unsorted array and swiped with the leftmost element, and that element becomes a part of the sorted array. This process continues moving unsorted array boundary by 1 element to the right. This is a really quick one, so I just set the speed really slow and just choose the selection and first put the random dataset. It's really quick, even with a really slow speed. First, second, I choose the reversed dataset. It's quick. Okay, for the third one, I introduced the bubble. The bubble sorting algorithm, sometimes referred to as sinking sorting algorithm, is a simple sorting algorithm that repeatedly steps through the list to be sorted, compares each pair of items and swipes them if they are in the wrong place. So it is a really slow algorithm. So I need to change the speed to first. So first I try with a random dataset. Let's start. Even I choose the first speed here, and it's still really slow. And let's try the worst case one for the reverse dataset. Yeah, it is done. It's a really slow algorithm. That's not a good idea to choose it. So for the first one is the merge algorithm. Conceptually, a merge sort works as follows. Let's divide the unsorted list into n sub-lists, each containing one element. A list of one element is considered sorted. Then we repeatedly merge sublists to produce new sorted sublists until there is only one sublist remaining. So this will be a sorted list. So let's say it in the application. First with a random one with a slow speed. It's really quick. And for the reverse dataset, yeah, it is quick. And for the last one is the quicksort. Quicksort is a highly efficient sorting algorithm and is based on the partitioning of array of data into smaller arrays. A large array is partitioned into two arrays, one of which holds values smallest than the specific values, say pivot, based on which the partition is made, and another array holds values greater than that pivot value. Quicksort partitions an array and then calls itself recursively twice to sort the two resulting subarrays. This algorithm is quite efficient for the large-sized dataset, as its average and worst-case complexity are of the O n log n, where n the number of the data in the datasets. So let's see it in the application. First with a random dataset. It's really quick, even I choose a really slow speed. Then with the reverse dataset. It's much faster than the selection and merge. So the only problem is here is like the how to choose the pivot. If you choose a very good pivot, it's really good. You can get a really good speed, but a better pivot can cause like the slow speed. So there is a 5 sorting algorithm, and for the conclusion, it's like for the big data set, it's a really good idea to choose like the merge sort or the quick sort. But like for the smallest one, for each algorithm, it's almost the same. So that's it. That's the video. And this video is modified by Jie Pan, and it is a reference from the ZoffZhang's code, and it's like the reference on the right top corner, so you can see it. That's it. Thank you for watching.